Okay, let's unpack this. If you've been following the journey into cloud architecture, you know the absolute foundation for, well, for nearly 2 decades has been the virtual server.
Right. AWS's Elastic Compute Cloud or EC2.
Exactly. But that model, of renting an operating system and a fixed block of CPU,
Hmm.
it's rapidly being superseded.
It really is.
Today, we are moving past renting servers and diving into services that represent, I think, the future of cloud economics. Renting pure code execution.
That is the pivotal shift. I mean, the great frustration of traditional IT, even in the cloud, was all that undifferentiated heavy lifting.
OS management.
Yeah, exactly. Patching, security updates, capacity planning. That's all still required when you run a virtual machine, an EC2 instance.
Sure.
So the core challenge solved by these new services is if your application logic doesn't require control over the operating system, why on earth should you have to manage it?
Absolutely. So our mission today is a deep dive into the entire compute landscape beyond EC2. It means Lambda, containers, and all those specialized services found in the source material.
Mm.
We really need to clearly answer the core question that drives architectural decision-making now. When is it better not to use EC2?
It's a huge question, and the correct answer drastically alters your complexity, your architecture, and, most importantly, your budget.
How so?
Well, if you choose the wrong tool, you're either paying way too much for idle time, or you're just introducing unnecessary operational risk.
Okay, let's jump straight into the serverless revolution then, which
Okay.
AWS Lambda really pioneered. The term serverless computing is still, I find, confusing to people.
It is.
Why is it called that? I mean, does AWS just magically run my code on pixie dust?
It's the industry's oldest trick question.
Yeah.
There are absolutely servers running your code. Of course there are.
Right.
The difference is the abstraction layer. Those servers are completely managed, provisioned, scaled, and patched by AWS.
So as the customer, you just don't see them.
You never have to think about the operating system, the hardware, or the scaling group behind it. You just upload your code and you define the logic.
So the extraction is total. And AWS Lambda is the star of this show.
Lambda is the purest form of paper execution. You upload your function, your small piece of code, and then you define triggers.
What sets it off?
Exactly. What sets it off? Maybe it's a new image being uploaded to S3 storage, or a message appearing in a queue, or an API gateway receiving a request from a user.
And the genius of Lambda, and really the reason it changed the cost structure for so many companies, is its relationship with idle time.
That's the killer feature. You only pay when that code is actively executing.
Right.
Let's think back to the EC2 world. If you had some mission-critical utility that needed to run for, say, 5 minutes, maybe once an hour, or even once a day.
You'd keep a whole server running 24/7 just for that.
Precisely. An entire EC2 server with its full operating system running around the clock just to be ready for those 5 minutes of work.
And you're paying the full hourly rate for 23 hours and 55 minutes of just idle, wasted capacity.
Exactly. With Lambda, you only pay for the time your function is running, and it's measured in milliseconds. This is transformative for applications with bursty or unpredictable traffic.
So you could have zero cost at 3 a.m.
You might have zero costs at 3 a.m. and then spike to hundreds of dollars during peak lunchtime, but you only ever pay for the actual demand.
That economic benefit is crystal clear. But what's the trade-off here? I mean, if Lambda is so perfect for small functions, does using it introduce any new complexities?
It does. The most frequently discussed trade-off is the cold start problem.
Cold start.
Right. Since Lambda scales down to 0 when it's not being used, the first time a function is called after a period of inactivity, well, AWS needs to spin up the container environment, load your code, and execute it.
And that takes time.
That initial latency, that cold start, can add hundreds of milliseconds to the response time. And for user-facing functions, that delay can be significant.
So serverless isn't always the perfect fit for, say, consistently high-traffic, low-latency applications.
Exactly. It's a key detail you need to remember. The cost benefit comes with a potential latency penalty if the function hasn't been recently executed. It's always about trade-offs.
Always about trade-offs. Okay, moving on from pure functions. The source material dedicates a large section to containers, a technology that feels completely ubiquitous now.
Oh, absolutely.
Containers aren't serverless, but they certainly aren't EC2 either. What critical problem are containers solving that Lambda and EC2 can't?
They solve the problem of environment parity. Anyone who has ever developed software knows that dreaded phrase.
But it worked on my machine.
That's the one. That moment when code works perfectly fine in your development environment, only to fail spectacularly in production because the environments diverge somehow.
Yeah, that's painful.
Exactly. And the root cause is almost always environment drift. A slightly different version of an underlying library, a missing dependency, configuration files that aren't identical.
And a container solves this.
It solves this by acting like a standardized, self-contained unit.
Let's refine that analogy you used. You compared it to a digital shipping container. What precisely is wrapped up inside that thing?
Okay, so it wraps up the code, the specific version of the language runtime it needs, like Python 3.8 or Java 17, all the necessary libraries, the config files.
Everything.
And critically, the operating system dependencies. But only the bare minimum OS needed to execute the application. Everything is bundled into one immutable, standardized package.
So the benefit then is guaranteeing consistency. You ship that container and the application runs exactly the same way, whether it's on your local laptop, a testing server, or in production.
That level of predictability is immense, and it guarantees immutability. You never modify a running container if you need a change. You build a brand new container image and you just swap it out.
Which makes deployments and rollbacks much simpler.
So much simpler.
Now, if we have hundreds or maybe thousands of these standardized containers, we can't just launch them one by one. We need orchestration.
You do.
What specific AWS services are designed to manage these container fleets?
So AWS gives you two primary options for orchestration, and the choice between them really defines your operational strategy.
Lay out that strategic distinction for us.
Okay, so first we have Amazon ECS, or Elastic Container Service. This is AWS's own proprietary management system.
So it's tightly integrated.
Very tightly integrated with the rest of the AWS ecosystem, and it offers a much simpler path to deployment and management. You can get a containerized app running really quickly with less configuration overhead.
And the second option?
That would be Amazon EKS, the Elastic Kubernetes service. EKS runs the open source industry standard, Kubernetes.
Ah, Kubernetes.
Yep. Kubernetes is often the choice for companies that need extreme portability. Maybe they run across multiple cloud providers, or they just need the mature, complex feature set that the huge open source community provides.
So the trade-off seems clear. Speed and simplicity with ECS versus portability and feature richness with EKS. But what's the actual operational cost of choosing EKS?
That's the real insight. The true cost of EKS often isn't the service fee itself. It's the operational complexity. Kubernetes is famously complex.
Right.
You have to hire or train specialized engineers, often called SREs or DevOps experts, who understand Kubernetes networking, scaling, and configuration intimately. It's a trade-off many organizations make, but it's a heavy investment in human capital for that promise of portability.
So you pay for simplicity and time and effort with ECS, or you pay for open source flexibility and portability with specialized expertise via EKS.
Exactly. And now we come to the next level of abstraction. Fargate.
Fargate. This is where the lines start to blur between containers and serverless. Fargate is the serverless option for containers, correct?
You've got the core concept. With ECS and EKS, historically, you still had to provision and manage the EC2 instances that would host your containers.
You're still managing servers somewhere.
You were. You had to worry about capacity and patching those underlying servers. Fargate changes that entirely.
So it takes the container image I created and just runs it without me caring what virtual machine it's on.
That's the Fargate promise. AWS handles all the server capacity planning, scaling, patching, and availability of the underlying virtual machines needed to host your containers. You focus only on the application code inside the container.
That dramatically lowers the barrier to entry for containerization. But this introduces another fundamental architectural challenge. If Fargate is so easy, why would anyone still choose to run containers on managed EC2 instances through ECS or EKS?
That decision comes down to two things: long-running tasks and cost curves.
Okay.
For workloads that run consistently, 247 at massive scale, there is a point where running your own optimized EC2 fleet becomes cheaper than paying Fargate's per second rate.
I see.
Fargate is amazing for elastic, bursty, or unpredictable loads. But if you know you need, say, 50 servers running all the time, managing your own fleet on EC2 often offers better raw cost efficiency at volume.
That's the critical comparison. Ease of management versus raw volume cost efficiency.
It depends entirely on the utilization pattern of your application.
Okay, we've nailed the major foundational pillars: EC2, serverless with Lambda, and containers, which can be orchestrated or serverless via Fargate. Now let's move to those specialized services.
The niches.
Yeah, the niches that offer unique trade-offs for very specific scenarios. These are often overlooked, but can be the perfect solution for a particular constraint.
And these specialized tools exist because not every application fits neatly into one of those three main buckets.
Let's start with Lightsail. This always appears to be the most beginner-friendly service.
Lightsail is the easy button. It's for beginners or small businesses coming from traditional hosting providers. It's designed to provide a simple virtual private server, or VPS, but without all the intimidating complexity of the main AWS console.
The source material mentions it bundles everything into a single fee. If I can run a simple website on a tiny EC2 instance, why use Lightsail instead?
Because Lightsail takes away all configuration freedom in exchange for simplicity. It bundles the EC2 instance, the storage, the networking, and often the OS image, like a WordPress setup, into one predictable monthly fee. With Lightsail, you choose from fixed templates. You cannot fiddle with complex networking, security groups, or instance types.
So it restricts your choice.
Exactly. And that restriction is the exact source of its simplicity. For a simple blog or a dev environment, that trade-off is often perfect.
Simplicity is clarity for a new user. Now let's go to the complete opposite end of the spectrum. AWS Batch.
Okay.
That name suggests massive parallel computation.
It is exactly that. AWS Batch is for highly parallelizable, non-stop, high-scale processing. Think of scientific simulations, media rendering, or genomic analysis. It acts like an intelligent job scheduler.
How does it manage that massive scale efficiently?
Well, you tell Batch, here are 50,000 tasks, and it handles the heavy lifting of allocating the right compute resources. Critically, Batch is very smart about using cost-saving methods like AWS Spot instances.
Spot instances. Those are the spare EC2 instances that are super cheap but can be taken away at any time.
Right. They're available at a massive discount but can be reclaimed by AWS with short notice. So Batch manages the risk of using those for jobs that can be paused and restarted.
So because batch jobs are typically independent and restartable.
Exactly. Batch can use the absolute cheapest capacity Spot instances, and you only pay pennies for huge processing tasks. It allocates either EC2 or Fargate resources as needed. You just upload the task definition. Batch figures out the most cost-effective way to execute the entire queue.
That efficiency is staggering for industries with huge, non-time critical processing needs. Okay, finally, Elastic Beanstalk. In a world with Lambda and Fargate, why is Beanstalk still relevant?
That's a great question that often comes up. Beanstalk is deployment orchestration, and it's specifically tailored for web applications that use a multi-tier architecture.
So it's not about running a single container or function.
No, it's about automatically managing an entire application environment.
So what does it build for me automatically?
When you upload your code, Beanstalk automatically provisions the whole ecosystem. The EC2 instances, the load balancers, the database connections, the auto-scaling configuration, and all the necessary networking to tie it all together.
I see the niche now. While Fargate handles the serverless execution of a single container, Beanstalk handles the automatic provisioning of the infrastructure around a complex, multi-component web application.
Right. It ensures all the components are talking to each other correctly from day one. It saves the developer the time of manually setting up that complex web infrastructure.
So it's still highly relevant for rapid deployment of complex web apps.
Definitely. Especially where you want automation and centralized management, even if the underlying compute resources are standard EC2.
We've established that the shift is away from just managing an operating system. The options now, from raw EC2 flexibility to Lambda's instant execution to Fargate's container standardization, are vast.
And the decision is no longer about what computing resource you need, but really what level of abstraction you need and what that abstraction costs you in governance and money.
Okay, let's run through a final synthesis check to drive these differences home for you, the listener. Scenario 1. You have a small piece of code that should only run when a new customer signs up, and you need to pay the absolute minimum while maintaining instant scalability. What tool do you choose?
Triggered execution, minimal cost, no idle time. That is AWS Lambda textbook case. It's designed for that kind of sporadic, event-driven task.
Correct. Now, scenario 2. You need to deploy a complex, stateful application that requires a guaranteed specific environment, a custom Python library, a non-standard OS patch, complex initialization steps. You're running this 247, and consistency between dev and production is paramount.
Consistency and specific environmental requirements demand portability and standardization. That means a container.
Right.
And you would then run that through an orchestration service like ECS or EKS. If cost at consistent scale is critical, you'd likely run that orchestrator on managed EC2.
Perfect. Okay, scenario 3. You are a small business launching a simple development server or a WordPress blog. You absolutely must have a predictable, fixed monthly bill and the simplest possible management interface. You don't need any advanced configuration.
That is the sweet spot for Lightsail. It sacrifices flexibility for simplicity and predictable bundled pricing. It's the ideal entry point.
We have successfully unpacked the three foundational pillars of modern cloud compute: EC2, serverless, and containers, and introduced the specialized tools that offer unique advantages when complexity, cost, or configuration simplicity is your primary driver.
And we've shown that the available options mean you should never use a general-purpose tool where a specialized one exists. The key is recognizing that management effort and cost consumption are now, inextricably linked.
Which leads us to the final provocative thought. If serverless abstracts away the physical server and Fargate abstracts away the underlying EC2 instance for your containers, you are fundamentally only paying for execution time and resource allocation rather than paying for infrastructure. This raises an important question for you, the listener. How does this fundamental shift, where you only pay for useful work, change the way modern developers think about application architecture and scalability from the ground up? Does the concept of server capacity even matter anymore? Or has it been completely replaced by execution budget? That's something worth exploring further.